Hello everyone, welcome back. In this particular video, we'll be discussing about the third problem of today's weekly contest, sum of matrix after queries. There are various different solutions to this problem. In this video, we'll be looking at how to optimize the brute force n square solution to order n log n solution by using binary search. If you are new to binary search or if you are practicing binary search, this problem is actually a great problem for you to practice. And by the end of the video, I am very sure you will be able to grasp something new and use that in the future context. So with that, let's get started. The problem states that you are given an integer n and a 2D array queries where each query will be of the following form: type, index, val. So if type I is equals to 0, it means we will set the value of the row with index I to this particular value. Similarly, if type I is equals to 1, we will set the values of this particular column to the given value I. After applying all the queries, you need to return the sum of integers in the matrix. So let's take an example. Let's say n equals to 3. It means we have a 3 cross 3 matrix where everything is filled with 0 initially. Now we have some queries. Let's start with the first one. First one is 001, which basically says the type of the query is 0. It means you have to apply the operation on a row. You will pick the 0th row and set everything to 1. So we pick the 0th row and set everything to 1. Let's take second query. In this one, it is a column type query. We'll pick the second column and we'll set everything to 2. So we'll pick the second column and set everything to 2. Notice that we have overridden the value which was set in the previous query for this particular cell. Now again similarly for this one, we'll pick the second row and set the values to 3. And finally we'll pick the 0th column and set everything to 4 by overriding any previous values. Now finally we need to return the sum of elements of this particular matrix. So sum of elements would be 4 plus 4 plus 4 12 plus 6 18 plus 4 22 plus 1 23. So the answer here is 23. So hope the problem statement is clear. Now how to solve this? Let's start with the brute force only. As you might already have guessed, the brute force solution is exactly similar to what we have seen in this particular example. For any query, what we can do, we can identify whether it is a row type query or a column type query, and then we'll go ahead and apply the operation to the given matrix, right? So every query here would take order n time because number of rows and number of columns is equals to n, right? So every query will take order n time. So you will build the entire matrix in order q into n time, right? After building the matrix, you have to iterate over the entire matrix to figure out the sum as well. So that will take order n square time, right? So this is the final time complexity, but this will surely not pass. Let's look at the uh, first expression here itself, q into n. So q is 5 into 10 to the power 4 and as is 10 to the power 4. So if you multiply them, that will not fit in the usual time complexity limit. So we need to optimize this. So let's try to remove this particular factor. Now, if we are trying to remove q into n, which of these factors you can remove? Surely you can't remove the factor of q because you actually have to iterate over all the queries at least once, right? So q can't be removed, so we can try removing the factor of n. What does this mean? Removal of n means we will not iterate over every cell of a given row or a given column to process every query, right? So what does this mean? This means that let's say we have a query of R04. It means we'll not go over every cell of 0th row and set its value to 4. Like we can't do this at all because if we do this, that will require order q into n time, which we are trying to avoid. So what should be what should we do? So basically, if we have to avoid that, we can simply say that, okay, let's not set everything here. Let's just try to maintain an array where each element would denote a particular column and another array where each element would denote a particular row. Now, whenever you get a query of R04, you will come to this row thing right? And set the value of 0th index to 4. So it means that you have to set everything to 4 here, right? Now similarly, R12, you'll come at the first index and set the value at 2. Now third query is C01. So we will come here, come to the 0th index and set its value to 1, right? Now R23, again same thing. You'll come here, come to the second row and set its value to 3. Now finally C21, you'll come here, set the value of second row to 1, right? Uh, After you have done this, notice that you need to find out the final matrix, right? So what exactly would be the value here? This says that everything here should be changed to 4. So it means this value should be changed to 4. And this says that everything in this particular column should be changed to 1. So in other words, this says that this 0 should be changed to 1. Now, which one of 1 and 4 will you choose? Like one of these will come here, right, at the end. So which one of 1 and 4 would come here? So let's like to get that answer, the one which comes later in this query would be the one which would override the other value, right? So we need to know where did this particular 4 comes from in this particular query, and where did this particular one comes from this particular query. Whichever comes late, that would be the final value of this particular cell, right? So we in like apart from storing this values, we will also need to store the indexes, right? Because we need to understand which comes first and which comes later. So we will now store a pair where first one will denote the index and second one will denote the value. So let's process this entire thing again. R04, basically it says that set everything in row 0 to 4. So we'll set this to 4, right? Now we'll also maintain that this query was from 0th index of the queries array, right? So this 0 denotes that it was from the 0th index. Now once let's proceed the second one. So in this particular case, you are setting everything in the first row to 2. So you will set this to 2. Again, you will say that this comes from the first query, right? So this was the 0th query, this was the first query. Now C01, this is the second query, right? It says everything, set everything in column 0 to 1. So you will just set everything here to 1, and you will say that this is the second query as well, right? Now R23, same, you will just set everything here to 3, and you will say that this is the third element in the query. Finally, C21, which says that I've set everything to the in the second column as 1, and the value here would be 3, right? 4. So this one would be 4. Now, uh, let's talk about this cell again. So here it says that everything should be changed to 4, and this particular thing says that everything should be changed to 1, right? Now, which one of 4 and 1 will you choose? As we have discussed, 1 comes at second index in the query and 4 comes at 0th index in the query. So clearly 1 will win here, and we will change this 0 to 1, right? Let's take one more. Let's say this one, or let's say this one. So in this particular cell, again, there are two candidates. This says that set it to 3, this says set it to 1. Now this comes, 3 comes at third index in the query and 1 comes at second index in the query. It means 3 will come later, and hence this will win. So we will just set this particular value to 3 here, right? In the very similar fashion, you can just iterate over the entire matrix. You will get the value at each and every cell, and you can just sum them up to get the final answer, right? Now, what is the time complexity of this entire solution? Notice that you are building this two arrays. Building this two array just require iterating over this entire query once. So building this two arrays will take order queue time. And then finally, you are iterating over the entire matrix to figure out the value of each cell. and how you are figuring out the value of each cell, you will just see which one occurs later, and that will be the value. So this is the overall time complexity, right? So this may or may not pass because n is at the very edge, 10 to the power 4. So I was not able to get this through. So we have to optimize this further. Now Q, there is nothing to optimize in Q. We need to optimize this particular thing, and we need to remove this n square to some sublinear time of n, right? So how to do this? Now where from this n square coming from? This n square was coming from the fact that we are trying to iterate over the entire matrix. And if we have to avoid n square, it means we don't have to iterate over the entire matrix even once, right? So we'll look at how to optimize, but for now, let's try to look at the pseudocode for current solution. The pseudocode for current solution is straightforward. Let's just get rid of this. So what we are doing, we are simply iterating over the entire queries, right? Then we are preparing the two arrays. So if the query is of type 0, it means it is of row type query. We will come to the row array. We will look at this particular given index and set its value to index comma q2, right? Similarly, for columns, we'll do the same thing. We'll come to that particular index and set its value to index comma q2, right? Now, finally, once we want to find the value in each of the cell, we'll iterate over each of the cell and see which one is max. Now, why max? Because you can see the first element here is the index, right? So whichever has first element greater would win. So that's why we have taken the first element as index. Now if we just do a max of these two, whichever comes greater would win. So max will return the final pair which would actually win. So we'll get the pair and we'll just take the second value from the pair and add it to the result. So this was the pseudocode for q into n square. Now we are trying to optimize this n square into some factor of n. So how to do that? So the new problem statement is given two arrays. We currently what we are doing, we are checking the max of this with this, max of this with this, max of this with this, and max of this with this, and then summing them all up. We are doing the same thing for the second element as well, and for the third and the fourth as well. So we need to somehow avoid iterating over every element of the second array for the first array, right? Because we don't want to have n square. It means we need to avoid this to loop and remove this n square to some n log n or something of that sort. Now, I would strongly encourage you to pause the video right away and try to think how, like, to remove the second factor from here. So hope you thought about it. Notice that what we are doing, we we want the maximum of 0 comma 4 with this, maximum of 0 comma 4 with this and with this. So if we take, like, first of all, the order here doesn't matter, right? So if order doesn't matter, what's the first thing you will do? You will just sort the array. So let's just sort this particular array, and the sorted array would look something like this, right? So this minus represent the minus one, like basically minus infinity or something of that sort. So let's just get rid of this, and this is now the new sorted version of the same array. Now you need to take maximum of 0 comma 4 with everyone, right? So there would be, because the array is sorted, there would be a point after which everything is greater than this, right? So let's say there is an index I which is greater than 0 comma 4. So because index I is greater than 0 comma 4, everything after index I would also be greater than 0 comma 4, right? Because the array is sorted. So what you can do is you can say that, okay, up till index I, 0 comma 4 would be the larger element. After index I, whatever is there in this particular array would be the larger element, right? So you need to now find index I. Now how to find index I? You can do a linear search here, but because the array is sorted, you can simply do binary search and find the first index which is greater than 0 comma 4. So you can, if you do binary search, you will end at this particular index, and you can say that for the first two element 0 comma 4 is the higher value. It means you will add 4 two times. So you will add 4 here, you will add 4 here, right? Now for the rest of the elements, you will add whatever the contribution of the second array is. So you will add 1 and 1. Now what is the complexity now? What you are doing for each element here, you are doing a binary search that will take order login time, right? Um, and after doing this binary search, you know that everything before will have the value 4. So you just need to do 4 cross 2 or whatever the value of I is. Now after that you need to sum this entire thing up as well, right? So sum 1 and 1. So this can also take order n time. So overall complexity would still be order n square, right? Or even worse in this case because this has extra n log n factor as well. Now how to remove this particular order n time? Again, I would encourage you to pause the video. This is very straightforward and we have solved this various time in our channel. So the answer is we'll just maintain a prefix sum. So we want the sum of every value in this particular range. What we can do is we can maintain a prefix sum from before. So let's say you have a prefix sum array, right? Uh, which will just store the value. So this is the first element which is 0, then 0 plus 0 which is 0, then 0 plus 1 which is 1, and then 1 plus 1 which is 2, right? So you will maintain a prefix sum array. Now whenever you need to find out the sum of values in a particular range, you can just simply use the prefix sum array. So you want the sum in this particular range, just 2 minus 0 is the is the final sum. So this order n would now be order 1 with a order n pre-computation, which will be outside of the loop, right? So the overall complexity is now order n log n, which will surely pass in the given time constraint. Even like it will also pass if n would be 10 to the power 6, right? So this is the optimized solution. So just to reiterate the fact, like we were trying to pair up this with every other element and we want maximum. Now we notice that order doesn't matter. So because order doesn't matter, we just sorted the array. Now we notice that we are taking the maximum. So at any given point, if 0 comma 4 is greater than, if is less than the current element, it means everything after this will be less than 0 comma 4 and everything before this would be less than 0 comma 4. So in that case, we'll add this 4 will be contributed I number of times, and everything after I would be taken from the second array. So for like fast for fasting this entire thing, we'll just maintain a prefix sum so that we can take the sum of a particular range in the second array within order one time as well. So the pseudocode for this particular thing would look something like this. So notice that I am only showing the code after we have prepared the array. The actual method of preparing this array is still the same. Um, we'll just iterate over that queries array and then prepare this two array, right? Now what we are doing, we are just sorting this particular columns first, right? So that will take order and login time, right? After that, we are maintaining the prefix sum as well because we need to figure out the range sum in the second array in constant time. So we just do a prefix sum here. After that, we iterated over all the rows. Now inside this, notice that we are not iterating over all the columns as before. Instead, we do a binary search for this particular value. Now, whatever this position is, everything before this position would be for everything before this position, 4 would be the larger value. So that's what we are doing. We are simply considering row as the larger value and adding its contribution this many number of times. For everything else, like in this particular part, we just need to do a prefix sum. So we will just say, okay, prefix sum of n minus prefix sum of the position. So that will give us the remaining contribution from the column side. So hope this entire solution makes sense. If you have watched till this point, I would strongly encourage you to pause the video and try to code this entire solution yourself and get it submitted in the Leetcode. that would help you actually grasp this concept, like grasp this concept even for a longer time. So this is the code. The code is very straightforward. We prepared these two array, rows and column, where each element is a pair, right? As we discussed, only thing we'll do is we'll just assign the particular index with j comma q2. After we have done this, we like this was the brute force solution that we have looked at, that has order n square complexity, that may or may not pass. So in this, what we are doing, we are just calculating the maximum and adding that to the result. But this is the order n square solution. So we optimize this further by sorting the columns first and then preparing the prefix sum. So prefix sum of 0, like this is one indexed and the given array rows and columns are 0 indexed. So that's why we subtracted -1, because this is one less best indexed. After that, we iterated over the entire row, and then we look at the position where, after which the rows R value is actually smaller than the value in column. So we found that particular index by this lower bound. Everything before this index, rows R is greater. For everything that is after this index, the value in the column vector is greater. So for everything before, we just contributed rows dot s, that is the value of the row. For everything afterwards, we just check whether there is any element afterwards as well or not. Basically, lower bound yields and if lower bound ends L, it means there is no element at all after. So for everything, rows like value at the row is the larger value. So if there exists something, we will just take that contribution from the prefix sum, right? And we'll return result. So hope this entire solution makes sense. If you have any doubts in the particular solution, feel free to post them in the comment section below. I would happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.